Assalamu alaikum. I am Asiya Islam and the last four digit of my ID is 1349. Today my presentation topic is process synchronization. So what is a process synchronization? Process synchronization is the coordination of processes that shares resources to ensure that data consistency is maintained and processes do not interfere with each other. And why it is needed: multiple processes may need to access shared memory or files, avoid conflicts, and ensure mutual exclusion, and maintain process coordination and system stability is needed for this process synchronization. And common synchronization problem. A common synchronization problem is a type of problem that occurs in concurrent programming when multiple threads or processes access and manipulated shared resources at the same time. These problems arises frequently when working with multi-threading or multiprocessing, and these key challenges in synchronization like race, con- race condition when two threads access shared data and try to change it at the same time, and secondly deadlocks when two or more threads are waiting for each other to release resources causing all to be stuck, and lastly starvation when one thread over gets access to a resource because other keep taking it. And then producer consumer problem. The producer consumer problem is a classic synchronization problem in computer science and concurrent programming. It describes a scenario where two types of processes or threads, producers and consumers, share a bounded buffer, and the these are arises the buffer and processes them their access to the buffer to prevent. And these are this problem arises because the producer and consumer need to synchronize their access to the buffer to prevent firstly buffer overflow and buffer underflow. When the producer tries to add items to a full buffer, it will be called buffer overflow, and when the consumer tries to remove items from an empty buffer, it will be called buffer underflow. Then problem overview for this synchronization is producer items and places them into a shared buffer, and consumer items from the buffer and processes them. And issues of this problem are race condition, deadlock, and starvation. Solution of this problem is using semaphores and mutexes to control access to the buffer. And then move to critical section problem. When multiple threads or processes access shared resources simultaneously, access may lead to a race condition, and this goal are ensure that only one threads can execute the critical section at a time. And this requirement for solution is mutual exclusion, progress, and bounded waiting. That's it. And common solution for this problem are mutex is ensure mutual exclusion by locking or unlocking access to shared resources, and semaphores use binary semaphores to control access to the critical section. And then Peterson's algorithm, a software solution for two processes only. And then move to mutex versus semaphore. Mutex is a synchronization tool that ensures only one thread can access a shared resource at a time, but a semaphore controls access to a resource by maintaining a count. It can allow multiple threads to access a resource at a time. Mutex binary is locked or unlocked, but semaphore can be binary or counting. Mutex owned by the thread that locks it, but semaphore has no ownership. And ensure mutual exclusion in the mutex, but control access limit uses, it will be called semaphore. Mutex block if locked, but semaphore blocks if count is zero. And uh, Example for mutex is processing or a shared resource, and semaphore example is limiting number of threads accessing a resource. Then what is bounded buffer problem is a classic producer or consumer problem where multiple producer and consumer share a buffer with a fixed size. The challenge is to manage the buffer so that producers do not overflow the buffer and consumers do not try to consume from an empty buffer. And problem for this scenario is multiple producers and consumers share a buffer of a limited size. The challenge is to prevent buffer overflow and buffer underflow. Solution for this problem is use semaphores and mutex to manage. Empty semaphore, full semaphore is needed for this solution. And then dining philosopher problem. The dining philosopher problem is a classic synchronization and concurrency problem where five philosophers sit around a table and attemptly think and eat. Each philosopher needs two frogs to eat, on their left and on their right. There are only five frogs available. Problem: a classic synchronization problem where five philosophers sit at a table thinking and eating. Each philosopher needs two frogs, and but there are only five frogs available. Challenges for this dining philosopher problem is deadlock. All philosophers pick up on fork simultaneously and wait for the other, causing a deadlock where no one can eat. And starvation: a philosopher may never get both forks if other keep picking them up first. Solution for this dining philosopher is mutual exclusion. Only one philosopher can hold a fork at a time and avoid deadlock. Use strategies like a resource hierarchy or asymmetric approach to avoid deadlock and avoid starvation. Ensure fair allocation of forks to all philosophers. Thank you. Here is my presentation.